lots of information there, guys. 1-to-1, right? That would be the big deal. Now, there are some really nice papers there. I do need to update them, add a few more, okay? The world of omega-3s is complicated. There are 2,000 downstream products between your omega-6s and omega-3s. This is just looking at this question of what happens if I have low omega-6s versus high omega-6s in your ratio of omega-3 to omega-6. And what happens to people who are living in Japan? They live long. Why? Their ratio of omega-6s to omega-3s happens to be different. So, yeah, you want to be living in India where the odds of finding the thing that turns off your inflammation, you have a 1 in 50 chance of finding it. That would be the issue you're dealing with when all of a sudden you're looking for that in your membrane and you keep releasing inflammatory ones and you end up with chronic inflammation and can never turn it off. That's and then eventually your body just moves on and leaves you in chronic inflammation. That's an issue. Okay? It's kind of shocking when we look at it like that in its simplicity, but that's what we're looking at. Fish, flaxseed, highest sources of these. Chia seeds could have been added to that. Lovely to realize. Does it make a difference if I'm a grass-fed cattle versus a grain-fed in omega-3s?
Yes.
Yeah, it would. This is omega-6, omega-3 ratio. It would make a difference. If you pick up from the store, and then I got to go forward, you guys. If I go pick up from the store an omega-3, let me tell you the problems and some of the things that you should be aware of. We have a market in dietary supplements who are largely unregulated. The FDA does regulate them, but they don't actually test all their products. They don't have the ability to say whether it works or doesn't work. Fish oils have existed and been taken for a long time. There's a lot of great correlative data. People have done a lot of studies on it. Reality. If you go and you buy the big horse pills, which are the cheapest fish oils that are on the shelf, what you will find is that there is most often a carrier oil with it, which is soybean, which happens to be an omega-6. And what they've done is they've formulated an omega-6, omega-3 together in a 1-to-1 ratio. Perfect. They gave us 1-to-1, except for what? You're trying to offset your diet by supplementing. Your diet's screaming high in omega-6s, and you need more omega-3s. You want all omega-3s. That would be your preference, because your diet is the problem. And so to fix that, you want it as high as you can. So that formulation's wrong. Secondly, the cheap ones almost always are coming, again, from large ocean fish. What's full of in large ocean fish that we worry about, especially if you're an expectant mother? Mercury. And you'd be right to be concerned. But if I take one that's been enriched for the omega-3s, we do cold distillation, we purify it, we remove the mercury. It's totally doable. And people do it all the time. It's not even all that expensive. It just isn't something done with the cheap ones. So save yourself a little nerve damage, brain damage, don't be the Mad Hatter, and go ahead and get yourself a little bit pricier one. I look for ones that are high in EPA and DHA. Why? Because that happens to increase your brain power. It's essentially tied directly to making it so you get those higher cognitive function. That's what you're really looking at, okay? All right, so lots and lots of potential benefits for taking omega-3s. That's all the time we have to spend on it. Yeah, go ahead.
So what do they do? Because I've seen that they also have just omega-3 tablets or whatever.
Mm-hmm.
Do they just like pull that out and like
purify
that shiz, or like how does that work?
That's all it is, yep. They can extract it, yep. And they're getting it from the oil, or they pull it from something like flaxseed. By the way, if you're at the store and you buy flaxseed in your cereal, flaxseed in your bread, it's the seed you're buying. Because if they had the ground up flaxseed, which has released the oil product, they would go rancid very quickly. So they sell you the seed But the problem is that when you eat the seed as a whole, you almost never get it into your body. See, it's not just too much fiber. You don't break the seed coat yourself. It passes through untouched. So unless you're gonna grind it with between your teeth, each of those teeny seeds, which is what they look like, it's going nowhere. Do I use it? Yeah, I grind it up and put my oatmeal. Grind up a little bit, put it in the fridge, no big deal. But it goes rancid quickly. Does that give you just an idea of the things you've got to be thinking about when you're talking about these? And if you were designing a study, to think about, do these work or not, okay? I do not fall in the category of saying that these will prevent your heart attacks. You just looked at coronary heart disease. But is it likely going to prevent inflammatory diseases? Yes, that's actually its role. And if I do lower inflammatory diseases, then what are the odds I'm going to impact cardiovascular disease? Much higher. That's the correlative that makes sense. But there are lots of other things that we can do to make heart attacks. Okay? Next class of lipids, we've got to talk about sterols. Sterols have, they're largely planar in the structure. Okay? They do have a polar head group. They've got this acyl side. This is a sterol. We build a whole bunch of things off this backbone. You should be able to recognize that structure. Not recognize it. Everybody think you could recognize that versus anything else you've seen? Yeah, you're in good shape then. That's good. Okay? Cholesterol, you make it, right? You do. Okay? You make also a lot of other things out of it. Okay? You also eat some of it, by the way. Most of us quite a bit. Makes a lot of hormones, makes a lot of other things. So here's some of the pieces of this. If we were in second semester, we would go through the entire metabolism for how do we get cholesterol made. Short answer is you're taking your acetyl-CoA, you're building up these units. There's actually 3 that go into making an isoprenoid unit. And once built, these become the structures that make these. Okay? It's really hard to connect all the dots here, but that's what you're looking at. So when you're blocking these with one of your, your statin drugs, you're even dropping prior to this. So yeah, fairly easy to block the synthesis of vanillate production. So go ahead.
So when we produce them, like, because there's those 2 types, the HDLs and LDLs, right? Through cholesterol.
Yep.
We produce both of them, right?
We do.
And so by taking, say, a atorvastatin or something like it blocks the synthesis of both of them.
No.
Just your LDLs, right?
Uh-huh.
The ones that are going out of your body that are bad,
Yeah.
right?
The LDLs is what you block.
How can it be selected?
Yeah.
We need to know this, like, just recognize structures as these, or just know their names.
Yeah, all I need is a sterol. So you don't need to be able to differentiate testosterone or estrogen versus your cortisol. You don't have to be there yet, okay? Just recognizing that if you are being asked about where cholesterol might be used, you'd be thinking, oh, cholesterol is used in my membrane, we'll talk about that. And you'd also be saying to yourself, it's also used for other things, okay? These were the steroidal anti-inflammatories. Cortisol is your stress hormone, aldosterone, dealing with your blood pressure, salt excretion. Estrogen, testosterone, you guys already know those sex hormones deal with that, right? So, all right. There's a synthesis for a little bit of it. This is the isoprenoid actual unit. Notice it's got a pyrophosphate on the end. That means 2 phosphates stuck there. And these get added together and together and together, making something known as a geranyl and farnesyl. The reason I bring these up is because we are going to get into talking about lipid anchors as we get into membranes. These are lipid anchors. And they're made of a precursor that actually leads to making cholesterol. So Kevin, in answer to your question, it is true that there are people who actually use statin drugs to block aggressive cancers. And the reason why, it won't kill a cancer, but it'll slow it down because it turns out your RAS and RO have this on them. And they are what we'll study in the last unit of this one, the last chapter. They happen to be G proteins. And so if I take the anchor that holds them to the membrane off, they're sort of floating around inside the cell. That's problematic. They don't do what they're supposed to.
Cool.
Okay, so that was a side note, but hopefully helpful. Sterols are also used here. This is what's known as a bile salt. Okay? So these are made up of typically an amino acid and the sterol put together. What are bile salts really about? Getting rid of your lipids, your fat. They happen to be something that acts as a detergent, okay? And so in breaking that up, this is a good way to look at what we call emulsification. So here's the lipid droplet times 0. Here's 50 minutes later. What's happened to it?
It's broken up.
It's all broken up. Now this is really what's happening in your sink when I add soap. It's breaking up the micelle into smaller droplets. For the purpose of why your body does this, it's so that your lipases can gain access to chop up the fat. Instead of working on one surface, they now have a lot of surface area. So they can digest it quickly, okay? All right, so and where is it stored? The gallbladder. Yes, do I want to know how come 3 of my siblings within 2 years had their gallbladder removed? And yeah, I'm healthy and I'm hoping to keep mine forever. My neighbor just had his pulled out and now he's had, sepsis all week and he's not doing well, and I'm fasting for him and hoping he's gonna make it. Yeah, gallbladder can mess you up. Actually, it's a fairly common thing that gets ripped out of people's body. And it's where you store your bile salts.
Isn't that like when I was a kid? They would tell us that we don't know what it's for, or is that something else? That's the appendix. Yeah.
That's the appendix, and we do know what it's for. It's no longer what's considered a vestigial organ, but every time people talk about it, they keep talking about it as if we're vestigial. We totally know what it's for.
Cool.
There's a few more structures I need to show you really quickly. Remember, it's structure recognition. This is going to be on the final and on the upcoming one. They'll be on the same places, so you've got to know these. We're going to start talking about the very same fat soluble ones that are in your paper that I want to get us to really quickly. Lipid soluble vitamins like A, D, E, and K. Okay. Now, vitamin A is called retinol. Beta carotene is found in things like your pumpkin, found in your carrots, right? It is chopped up and made into vitamin A, retinol, okay? Which then is mutated just a little bit to make something like cis-11 retinol versus cis-trans. This is put in rhodopsin in your eye. My major professor's expertise was in rhodopsin, finding that GPCR. And this was his work, okay? So looking at this molecule, 1 photon switches that from cis to trans. That motion causes you to register with 1 photon, I just saw light. Take you in a cave and shoot 1 photon, you can register, I just saw light. Really? Yep. And you'd be right. It's that sensitive. So that's how it works. That's the motion of the molecule, okay? Retinol, coincidentally, there is a receptor on every cell of your body for retinol. And it actually increases cell growth and division, which is why a tangent of retinol put downstream that we use, which I'm not thinking of it right now. We'll talk about it later, but Accutane. Some of you shake your head. I know what that is, right? For acne, it's a retinol derivative. It's also one that is a high mutanogen. They won't even prescribe it if you're female anymore without birth control. Why? It's that potent. What's it acting on? Every cell of your body is building fast division, including those that are building your gametes. That's messing you up, right? Okay, so there you go, understanding some of that. Okay, so there is vitamin D. What does it look like? It looks like a sterol. So you've got to recognize vitamin D is sterol-like, in addition to the rest you looked at. Okay, so vitamin D, D2, D3, we could go into the fun of that, I'm not going to at this point, okay? So that's what it looks like. Promotes calcium levels. We will talk, we always think about this in terms of makes my bones hard, and that's good, because it is responsible for that. The other piece that, because I did research in diabetes, I'll tell you is a correlate in every patient that had diabetes. They all have low vitamin D. Everyone. One of the things that's interesting is the correlate calcium is releasing in the, when we depolarize the cell, calcium rushes in to release your insulin. Can't release the insulin if my vitamin D's wrong, because it actually controls your calcium levels. Fascinating. By the way, does that mean that's different for different ethnicities? Yes, because it's light activated. Where can I get most of my vitamin D? Just go out and get some sun. Like my buddy I was telling you the other day that went and stood in the sun every winter from Egypt, because he's got dark skin. And he says, I need light. Okay, so vitamin D, is it worth getting? Yeah, you live in a northern climate, you need more vitamin D. Probably worth looking at. By the way, vitamin D gets research over and over again as being one that many doctors are now going, wow, this is good research, it's solid, big deal. Because where do we all live now? Indoors.
So this might be like a branch question off of that, but as far as, you know, when muscle contraction happens, they use that calcium as well.
Yep, we do.
Is it the same process as the insulin as well? As far as like, you have your
Yeah, we'll talk
action
about
potential
that.
go?
We'll talk about that trophin response, yep.
Okay.
Wow.
Yep, yeah.
So for people that like have to supplement some of these things, does it matter which one they choose to supplement, whether it's like D1, 2, or 3?
D2 or D3 would be the
Or
ones
D3,
that
D3.
you're getting, and the one's synthesized by you, the other's synthesized by fungus, and so we get it input in your milk, because it's easier than getting it from a mammal. Okay. So, yeah, and studies suggest no, it doesn't matter.
Just like as long as you get it.
Yeah, and when they started supplementing with it, the lack of rickets, which was when they had people that were bow-legged and that had problems with it, bone density went dramatically down because of that. Yeah, go ahead.
In northern climates, shouldn't we usually all be supplementing vitamin D in the winter anyways? Because
You should.
can't really get enough.
You should, and especially if you happen to have an ethnicity where you have a darker skin pigment, which is also, by the way, why you would say, why is it that people who are living in northern climate, eating a Western diet, have higher and have dark skin pigmentation? Why do they have higher incidence of type 2 diabetes? Is it cultural or is it actually biological? A huge part is biological, by the way.
Okay.
Oh, doggone it, I thought it was just because they like fried foods more than me. Nope, that's true, but we all like it. Vitamin E. Vitamin E is responsible as a free radical scavenger, okay? What's it doing? It actually is recharging vitamin C. Vitamin C, sorry, recharges vitamin E. Vitamin E is responsible in your cell membranes for actually getting rid of the lipid peroxides, which are responsible by get those lipids that go into oxidative damage. Vitamin E is there, so fat soluble. Now, I'm looking at vitamin E, and you're saying, do I need to know all forms of them? No, but you do need to recognize them. There's vitamin D, there was vitamin A. Does vitamin A and vitamin E look alike?
Kind of.
Similar, but not the same. Do you notice in all of these that I keep seeing this little pattern?
Yeah.
That's the same pattern that was making up the cholesterols. That's the isoprenoid unit. It's in all of these. Everything I'm showing you, it's in. They're all, that's what this little, these are all isoprenoid units that make all these up. So, warfarin, isoprenoid units. Vitamin K, isoprenoid units. Vitamin E, wow. Yes, ubiquinone, code Q10. Yes, vitamin E, it's got the isoprenoids in it. Prostaquinone, this is the plant form of it, okay? And so, yes, these two right here are in photosynthesis, and one's in the electron transport chain for you, other than photosynthesis. Warfarin, anticoagulant, right? Rat poison. Vitamin K causes blood clotting for you. Okay.
Do we need to know the other name for vitamin E, the tocopherol, or do you, is it?
Alpha tocopherol or gamma or delta. You should know that, okay? I probably shouldn't tell you not to.
Okay.
Just like vitamin C, you should know it's ascorbic acid.
Okay.
Okay? So they'll show up, okay? Okay, statins that made up statin drugs, guess what they're made out of? Sterol derivatives. Oh, how funny. Okay. I told that there was an antibiotic that was a whole new class of molecules. This is where I'm bringing it up for 2 seconds. Here you go. It's called the dino or darobactin. It's responsible for actually blocking the entry of it, and it turns out we can block it with this. So these are, it's a conserved region. It's found in all of our prokaryotic cells, and we can block them with this. It's kind of a cool little drug, the dinobactin, that gets in here and blocks this transporter. So not too bad. Okay, blocks the proper folding of it, and compromises membrane integrity as a result of it. So whole cool stuff about that. Awesome. By the way, there's your birds, color agents. What do they look like? They're made out of isominoid units. Are you seeing that methyl, that couple carbons methyl, couple carbons pattern showing up?
With the double bond,
I'm seeing that now. So you need to know what an isominoid unit is. You need to be able to recognize on the test. You need to know what's attributed to it, okay, because they're lipid class. This is how I told you we extracted lipids. Methanol, water, chloroform, lipids. Throw them all in the mixture. This is called a SEP funnel, right? And then when I did, I got different ones, and the heavy ones on the bottom happen to be the ones that were my lipids. When I separated them, which ones do you think were at the top? The tags or the phospholipids?
The phospholipids?
Triglycerides. If this is a silica gel, which one's going to go in the solvent that you go forward? The ones that are most non-polar will be the ones moving fastest. The ones that are most polar will be the ones at the bottom. Should have told you what the matrix was, but that's how they classified them. Okay, and yeah, sterols fall in a whole other category. So this is how we do that. We saponify them, which means I turn them into soap by exposing them to a base. I can also hydrolyze them by putting them to an acid. There are other methods we can do, but that's how that's made. There's a saponification method. Awesome mechanism, cool. I do that all the time so I can run that on the GC or GCMS. And when we turn around and we look at not the fatty acid, but the fatty acid methyl ester. Why would I add a methyl ester to a fatty acid and it be good for going on to a gas chromatography? You did gas chromatography in your OChem, where you injected your molecule into something that was hot and came out the other side. Why would I want to take this polar molecule
And add a methyl ester.
and make a methyl ester?
Is that to make it? Yeah.
It would. I'm blocking the charge group on the carboxylate by making a methyl group on it. This is now an ester, much more volatile as a result. Changes the intermolecular forces. So I can get it into the gas phase a lot lower temperature. Yep. So what am I doing to the boiling point? Well, it was 116, it's negative 69. 144, it's negative 36. Okay, I think I'm changing something. Yep, that's what we're talking about. Okay, gas chromatography, get them hot. Separate them based on how they interact with the stationary phase. For fatty acid methyl esters, we put them in a waxy column. What was a wax? Tell me, here's somebody else. Do you remember what we made waxes with?
Esters.
What was wax?
Oh, yeah, like a long chain.
I have it here. Esters
That's weird.
of long
Oh, yeah, that was good. Isn't that exactly what I
And then some other stuff.
You looking? You looking?
I have it
Picking
in
it
my
up?
notes right here. Waxes, esters of long chain.
It was a fatty alcohol reacted with a fatty acid to make it into an ester bond between them, but there was no glycerol piece. That was a wax. Oh, that wasn't on my big chart. You're right, but you should probably still know it, okay? All right, cool. So there's some different mass spec. Yes, there's another derivatized element of it. Yep, cool. That was chapter 10. That was fantastic, because what do we need to do today?
Something else.
We should talk about this awesome paper you were supposed to read. What a great idea. Was it short?
Yeah.
It's a really short read,
It's
okay?
like less than a paper.
Asthma is currently one of the most common chronic disorders in childhood, affecting an estimated 7.1 million under the age of 18. 4.1 million suffering from an asthma attack within the year 2011. So annually having that asthma attack. I'm not going to ask personal stories, but if you've ever watched somebody having an asthma attack, like I've watched my child have an asthma attack, what does it do? It's scary. They feel like somebody's sitting on their chest. It's like they're suffocating. It's a very, very bad feeling. You don't like this. So what's the cause? Now I want you to know that this paper is very debatable on whether or not it's true or not, but it's a great paper to illustrate some of the things that we need to understand about our fat soluble vitamins that we just learned. Underlying, not fully understood. Developing oversensitive immune system, a big role. Inherited traits, types of airways affected at a young age, exposure to environmental things like cigarette smoke and air pollution, and pollens and dirt. I don't know if you've ever been in somebody like my background, where I served a mission in Detroit, but when you go into somebody who's in a very poor class of where they live, it is common that they have dirt, animals. It is common they have smoking, that they have lots of these things that just exist in the environment. So don't look past those as also being pieces of the correlate that you're about to see. So then when they have a poor diet, because they don't get a lot of fresh fruits and vegetables in their life, and then they happen to be missing a whole bunch of their vitamins that we're about to talk about, register, it may not be the only factor is the diet, okay? All right. So here's the questions you're answering today. They're fairly straightforward. You will need to know these for the upcoming exam. Any one of these could be on multiple choice, maybe two of them. But you want the answers, there's no right on it, you just need to know them. You should know your fat-soluble vitamins. Check. Know that, okay? What are the 3 fat-soluble vitamins most likely associated with preventing childhood asthma? They're in the paper. Are there any water-soluble vitamins mentioned in this study as well? And you should be able to register their water-soluble vitamins, okay? By the way, that's full. Find it. In the Fogarty study, on 2,633 adults, what was the observation? So find that. What was the observation about it? By the way, I just told you that vitamin E and vitamin C are correlated together. Vitamin C is a water-soluble vitamin. It's an antioxidant. What does it do? It recharges vitamin E. What did vitamin E do? We just learned it. It handles lipid peroxides, which are created because you've got an unsaturated fatty acid that reacts with oxygen, and then you end up with your whole membrane falling apart on this cell, which causes inflammation downstream, and it's a free radical generator. How early was intervention to prevent childhood asthma suggested? And just kicks and giggles, there's some great sources of your fat-soluble vitamins, and so we'll start looking from there. Okay. Okay. So answer those questions. Let's see if we can't get the answers. Got a good solid 20 minutes.
Cool.
Feel pretty good about myself.
That was good.
So what I got, I read it.
ADEC.
Or add K.
I've never thought about it like that. I've always just said ADEC.
Why not K?
Yeah, well, once you're fine.
Reproduction. Oh, yeah, K is
I
What is
learned
that?
in ADEC. I don't know.
That's because it's alphabetical order, huh?
Well,
Yeah.
oh, yeah.
Okay.
So number 2.
Oh, I'm sorry. Yeah, what are the 3 fat soluble
E for
vitamins
sure,
most likely
because
associated?
it's in
So
the paper. D as well because it reduces inflammation.
Yeah.
I don't know about K.
the fat soluble one.
Probably K too, because I don't think it does anything. It says with anti-inflammation.
So you think it's EDK or the
Yeah.
most likely?
So